So pre-train and build models that understand the world in general. But the value inside a company is specific. To unlock it, we need a different pipeline, right? A post-training pipeline that delivers an agent the right context from the right order under the right conditions. Open data spaces are designed for that pipeline. It's also our technical answer to a principle world leaders endorsed in 2019, DFFT, Data Free Flow with Trust. Open data spaces stands on two ideas and one reality. The first idea is, of course, data spaces, proposed in the United States in 2005 by Franklin from UC Berkeley, Halevi from Google, and Mayer, a way to manage many heterogeneous data sources without forcing them all into a single model. The second is data mesh. So we combine them, the cross-source thinking of data spaces with the product thinking of data mesh. Then we ground both in one reality that matters, industry. So the distributed cross-border world of real operations where data is owned by thousands of parties who will never agree on a single schema. What result is not a product. It's a paradigm for distributed data management, expressed as an open protocol anyone can implement. When data crosses organizations, the context layer has to answer three questions that data mesh left open for three major issues, which is where to get, what to mean, and who and how to use. And this is where open data spaces kicks in. So let me explain in detail. So where to obtain it is all about the question, is the production data reachable at all and can be identified while preserving each local identifiers? What it means is about when one dataset says altitude, for example, does it mean height above sea level or height above the ground? So this is completely, those are different numbers in semantics in aviation, for example, right? And lastly, who may use it and how? So which company operates this agent? Can it be trusted? Or may it use the data only for analysis or for more? So we answer with three pillars: for where, data addressability, and discoverability. For what it means, ontology, and semantic interoperability. And for who and how, identity and usage control. So together, we make distributed data findable, understandable, and at the same time, governable across boundaries with no center. Let me begin with our assumption because they may sound unusual. So first, we assume that providers describe their own data and that those descriptions are incomplete and always evolving, right? And crucially, that incompleteness must never be a reason to shut a provider out. And yet we assume that consumers, or agent in this sense, right, still require real guarantees of reliability. Most systems force a choice between openness and rigidness, but we refuse that choice. Our answer is what we call double product quanta model. We treat the meaning of the data, the ontology, as a product in its own right, separate from the data itself. So why does it separation matter? So consider a plant that first tracked its own machines only as running or stopped in Boolean, right? And after a quality incident, the team suddenly needs maybe abnormal vibration, overload, what their manual interventions or humidity or etc. In a conventional system, that means rewriting tables, migrating history in ETL process, and rebuilding applications. So this is a structural earthquake, right? So when information model is a separate, living layer, you simply add the new concept on top, and the original records remain untouched. So this is what we are thinking. Most system changes in industry are caused not by the data changing, but the meaning of the data changing. We designed for exactly that. So beneath this lies a deeper shift. The classic relational databases takes the concept of what is called closed word assumption, CWA, that everything is real can be defined in advance as an infinite set. But in reality, across organizations and boundaries, no one can predefine who holds what. So, meaning lives under an open word assumption, OWA, where not yet known does not mean false, and where strictness is genuinely required. For example, an air traffic system that must guarantee, the latest flight plan. For example, we close that part and guarantee it. So loose where it should be loose and strict where it must be strict. We call the principle schema flexible. Data first, meaning attached afterward, atop the lakes or warehouses you already own. We've got two priorities. So first, the meaning is alive. Domain context is not fixed at design time, right? It's updated every day in real operations. So we do not provide static catalog or repository over semantics. Rather, semantics are returned by its endpoint as dynamic viewer based on query. And we are aware that graph query is so inefficient that consumes so much compute. So that's why borrowing the concept of search engine, so we have semantic crawler and cache mechanisms are introduced in our architecture. Another thing to take into consideration is that each domain carries each different semantics. This is called semantic gap, and we solve that problem with what we call dynamic ontology, in which large language models propose how two vocabularies might map, and the ontology itself check and constrain those proposals. So the machine processes and the structure verifies. So together, they narrow the gap between the organization without ever halting the flow of data and without forcing thousands of millions companies to agree on the single matter of dictionary in advance. Then ontology graphs are connecting across domains and organization, just like internet. Second, we resolved an old tension. Making data easy to find pulls in one direction, and controlling who may use it pull the other. We bring them together by combining semantic web technology with a zero trust architecture. For permission, for example, we model the relationship between a person and a resource as a graph and let the system reason over it. So given Alice belongs to one company, so to this company, the company holds this contract, therefore she may see this data, for example, like that. And Alice, of course, could just and easily be a crawler or agentic AI. So open enough to discover, strict enough to trust is the important thing. We are creating the mixture of the internet and intranet, so to speak, where you decide what to provide others. Consider what an agent truly needs. Not merely an answer, right? But knowledge of what is true, what things means, and what's permitted to do. So today, when that context is missing, agents just guess they waste effort, and they make confident mistakes. The whole industry is converging on the same insight from many directions. An agent needs a reliable map of meaning to reason over, not a pile of disconnected files. So, in open data spaces, we express that context as a graph. We call graph is context. And because the graph carries identity, meaning, and permission together, an agent can reason over it rather than guess. It can infer, actually, rather than just gamble. That's what turns an agent from the answer engine into a reliable action engine. In this sense, distributed data management is the post-training pipeline for agents, the layer that hands them the world they actually operate in. I see a future in which humans and agents work side by side on real operation of the real economy, and in which we can trust what the agents do because, we can explain where the context came from, what it meant, and who allowed it. There is also an economic turn here that I think it matters. If a provider cannot control how its data is used, it will only ever share its cheapest or least valuable data, right? So we build in usage control and data contract and policy from the start. The moment a domain owner can set the terms, the data it has girded for years or maybe decades finally become a capital, an asset that returns value and future cash flow again and again. And then the picture changes at the scale of whole economy. The dark data inside the world's enterprises, and most of it is dark, becomes a foundation for everyone that can be built upon without anyone having to surrender control. That's the market that barely exists today. I believe it's one of the largest opportunities in front of us. So, data was eating the world, context is the next layer. And from our perspective, graph is context and open data spaces is the pipeline. We're now building this in an open protocols, open source reference implementations designed to remain neutral, vendor by vendor and country by country. It belongs to a global community, not to any single power. So, if it resonates with you, whether you're a researcher, a developer, or simply someone with the data worth sharing, we will be glad to have you join us.